Hello, and welcome to CIS125. If you are looking for CIS125, discrete math for computing, you're in the right spot. So I guess you got the first thing out of the way is you're able to find the first lecture. Now that's always good news because all the lectures are going to be placed all in the same spot. So let's get started. My name is Professor Bob Hendry. Please call me Bob. And today what I'm going to do for this course is I'm just going to kind of go over the who's, what's, why's, how's, and all that other good stuff. Now, for those of you that have had me before in various classes here at the college, you could probably attest to this fact that the first class for me for any of the courses that I teach is kind of difficult because I tend to kind of channel surf a lot because what I see here is, on the first day of class is, I review my syllabus and I kind of go over, what our objectives are, and I kind of see everything at once. You guys don't. I mean, you guys are sitting there wherever you're at, and you're kind of looking at the stuff and really not knowing what to expect. And I'm kind of in the other end of that coin or the other side of that coin where I kind of know what to expect, and, I kind of have it all in my head all at the same time. So where to start? And that's always my challenge. So that's going to be my objective for today, really, is to go over the course and kind of let you guys know what you're in for and to kind of get you comfortable with the material. And, by the end of our class today, you'll be able to at least leave class with an understanding of what this course is all about. Because if you look in the course catalog, there's really not a lot there. I mean, you get a couple of sentences and you're like, yeah. All right, well, what is this course about really? So I'm going to try to go over that today and to kind of get you, a path to success, if you will, from now to the end of our time together, which sounds horrible. But so anywho, let's go over the course. In the next 40 minutes or so, I'm going to kind of show you what we're going to be covering, and more importantly, I'm going to show you the formula for the class. You're like, what is the formula? Basically, how you're going to get your assignments, how you're going to submit stuff, what you're evaluated on, and all that other good stuff. Now, what you see here on the screen in front of you is you see our syllabus. Now, where is our syllabus? Now, don't worry about it because you got your syllabus in the email that I sent you. As a matter of fact, if you're hearing this, you already know where the syllabus is because I gave you the link. I gave you two links in the email that you just opened just not too long ago. The first link is the video that you're watching right now. The second link is the syllabus, which is what you're looking at right now. A little more on email in a little bit. So anyway, let's go over kind of this course and what we're going to be covering. Now, I'm not going to really be reading this to you because you have the link to the syllabus, and believe me, you're going to be going to it quite a bit. More about that later. But as far as the course description goes, this is an applied mathematics for computer science course. Now, that's as scary as hell to a lot of you because a lot of you are first or second year students, and immediately you're starting to run towards the door because you don't like math classes. And I kind of got good news for you in that respect. I don't like math classes either, and I kind of made my living doing math, especially applied math. And in other lives, I do a lot of predictive theory, a lot of descriptive theory, a lot of predictive theory. I'm an algorithm guy, and I also do a lot of big data algorithms. So math is kind of something that's ingrained in me. It's something that I never really learned. It's something that I kind of am. If that's kind of, I guess that's kind of hard to explain, but it's not. Math to me isn't a learned thing. It's something that I've had in my brain that I've kind of developed as I've progressed, in my career and as a teacher. So I'm not a traditional math teacher, which probably will become a relief to most of you, hopefully, because I don't like the way math is taught in a lot of courses. In my opinion, I think math is made to be a lot harder than it really should be. and looking at some of the math courses I've taken, and also reviewing a lot of the classes as me being a math professor. I'll look at some of this material and I'm just like, you know what? I'm like, dude, this stuff isn't that hard, but it's presented in a way that you think you have to be Albert frickin' Einstein to understand it, and you don't. Math is fairly easy. We're all wired and we're all born to understand it. And it's not something that's really that difficult to understand if you break it down into simple bite-sized chunks. And if you use some sort of application of mathematics while you're learning it, it becomes very easy to understand. So basically, with that in mind, there is a genre of math that you need to learn for your studies in not just in computer science, but even if you're in a technical field such as networking or I don't know, let's see what else, or like even support, or if you're not going to go into computer science proper and you're going to be more of a web developer, which technically is more of a business, application rather than the computer science or a developer algorithm sort of a person. Discrete math is the kind of math that you need to learn to get through that. Now, discrete math is kind of a strange bird as far as what genre of math it is. I mean, because you've all had, your math in high school. Hopefully, the more the better. I mean, as far as I'm concerned, but knowing some of you guys, you probably couldn't stomach it, any more than you had to. So as you're going through math in high school, you probably just did the bare minimum. And, quite frankly, I don't blame you for that. I mean, I've seen high school math and it sucks. Yeah, I probably wouldn't want to go as far as I could anyway. But for those of you that did, congratulations. I mean, if you made it all the way through like trig and calculus and, maybe even a finite, that'd be awesome. And sometimes some schools kind of switch those around a little bit. But anyway, those genres of math have been around for a while, right? We've all heard of those, right? Calculus, we've heard of finite math, we've heard of trig, geometry, algebra. Okay, these are the different, the different genres of math, if you will. They've been around forever. There wasn't really an invention of algebra. Well, technically there kind of was, but I mean, it wasn't like someone at some specific time says, hey, behold, we have algebra, here it is. We have, geometry, here it is. Discrete math actually happened like that. It really did. And we're going to have more on that a little bit later. But discrete math actually came about in the mid-'80s, where different powers that be and instructors and universities realized that there are different skills of math that you need to know to be in the computer science field, which is strange as far as I'm concerned, because computer science has been around for a very long time, but we only really applied a discipline of math to it very recently. But there's good news in this, because some of you are really freaking out. Don't. It's not that hard. Discrete math is really kind of like, what's the word I'm looking for? Kind of like the general mathematics for computers. Now, what's general mathematics? Well, you guys know what that is. You probably have had it in middle school and certainly maybe even high school. I mean, before you went to algebra, you had general math. I mean, even basic math. And before you went on to trig or calc, if you ever made it that far, you had general math. Now, just as an example, algebra, for example, if you look at algebra, it's really only 4 operations. You add numbers, you subtract numbers, you multiply numbers, and you divide numbers. That's it. Did you ever see the movie Bull Durham? It talked about baseball. It's baseball. It's easy. You throw the ball. You hit the ball. Math is like that too. There's only 4 things that you could do with it. I mean, you add things together, you subtract things, you multiply things, and you divide things. Now, the good news is all of you learned this when you were in elementary school. And also the good news is all of you learned this with whatever language you learned, whatever schools you went to, you learned it kind of the same way. So math and general math is very easy to understand because we all kind of know it. So let me kind of get to my point here. So anyway, when you went into algebra, you learn kind of more complicated ways to do that. But algebra is still multiplying, dividing, adding, and subtracting. When you got to calc, it was just, it was just those four operations, but basically, the calculus, meaning that you had more of them and you kind of had what I call moving targets, where, the math was a little bit more complex, but it basically fundamentally was not changed from that general math that you learned when you were, in second grade, throwing up in your gym locker. And so discrete mathematics is kind of like that. It's the general math for computer science. Now, I'm not going to blow your mind, or try to, at least right away, and impress you with all these formulas and all this cool crap that we could be doing and impress your neighbors and your girlfriend, your bartender, your parole officer, or whatever. But we will, and we'll get to that, once we get an understanding of how this works. So discrete math is really where we start. This is where we start when we have what's the word I'm looking for? When we've decided that we're going to make a real attempt at computer science. Okay, this and again, this is kind of opinion. My opinion is, if you're going to be a web developer, you probably don't necessarily need discrete math, because that's not really a mathematical thing that you're doing. I know we can debate that. Some of you, I can feel through the internet kind of rolling your eyes to that, saying, yeah, well, I use math all the time, and you're probably right. But anyway, discrete math is kind of when you've turned the corner a little bit, or in your case, if you're taking this course, that you're going to be going into computer science. Very few people take this as an elective. Not that it's a bad thing, but it kind of lends itself into a gateway, into a different sort of way of looking at computer science for your major. Now, discrete math, again, is something that was kind of cobbled together over the past 40 years or so, and there's not a real definition of it. Now, in your reading, more about that to come, you're going to see different definitions of discrete math, and that's to be expected. Different professors, like me, and I mean, over we could go to the pub house or the ale house after class with other professors or computer science professors, and over a couple pints we could talk about what is discrete math and not really have a wrong answer. I mean, there can be some wrong ones, but I mean, generally it's open for discussion exactly where the borders are. So we're going to be going over all that. So anyway, in a nutshell, that's the long answer for this course description. This is what you signed up for, and this is what we're going to do. Now, again, I don't want you running towards the door, because I think I have, a firm handle on this. I mean, I've been doing this my whole life. I'm not going to give you my autobiography, but you'll learn a little bit more about me as I go. But I tend to explain this in very common terms. I'm not saying I'm a good teacher, but I always can be better. But some people call me a math teacher for people that don't like math classes, and I think that's an honor to have that distinction. And I will present this to you in very achievable chunks, where I won't make it harder than it needs to be. Sometimes it is hard, but I want you to build that trust in me, that I'm not making it harder than it needs to be. Always know that I'm making it, at least attempting. I mean, sometimes I'm not always successful, but I'm attempting to make things as simple as possible for you. So if it seems complicated, that I'm trying to make it as simple as I can, but we'll get you through this. Now, here are our learning objectives. Now, don't hold my feet to the fire on this one, right? But because they're going to change maybe a little bit, but in general, this is what we're going to do. We're going to start with mathematical proofs, and we're going to talk about constructing solid algorithms, solid theorems, solid proofs, and we're going to kind of connect all the dots. You have to think logically to have a mathematical brain. And the good news is we already are built with a logical mind. So what we're going to do is we're going to take what we were born with, like my grandmother always said, use the brain God gave you. We're going to start with that. We're going to start with what you already have, and we're going to kind of refine it and put it into a system that you can define and put labels on. For example, like when we put together theorems and proofs, and the the steps in actually putting together a good theorem and a good proof. Now, if I kind of talked in circles, that's fine. I mean, we're going to define what this is in a little bit. And sometimes what I do is I get a little bit long-winded and I talk around things when we're going to get to it anyway. So don't panic. And if you're taking notes, don't even bother. Put down your pen and just listen to what I have to say. A lot of this is going to be all of it's going to be described in a lot more detail. So just listen to this and we're good. From there, we're going to talk about combinations and permutations. Now, we're going to start simple. We're going to talk about how many different ways can we do things. And we're going to start out with some academic exercises, like if you have three numbers, what are all the possible blah, blah, blah. I mean, we're going to start with I think, kind of ridiculous academic exercises like that just to kind of get your brain going. And then we're going to go into more applied real-world applications of that. And I want to point that out is when possible, I'd like to do that. I try to put context around stuff. Again, going back to some of my math days where I remember taking math finals, as a graduate student and, as a pre-doc. And some of these math stuff was just so crazy where, after an hour going through an equation, the answer would be x minus 5 over 3. Okay, great. What the frick does that mean? I forgot what that meant. So I kind of take that into teaching where I try to get context around it so we know what we're quantifying. It's called a quantifiable number or the dimension of a number. We'll talk about number theory later, but a dimension of a number is some application of it. And so when we're going over like combinations and permutations, I'm going to kind of lead you through some real world settings. From there, I'm going to teach you the basics of probability theory. Now, this is something I know a little bit about. It's been the subject of a few things that have been important to me through my career, and I've contributed quite a bit to the field of probability theory. More on that later. Then we're going to talk about exactly how we can look at different events, or we can look at different samples and we can make predictions based on them. Just to put it in simplistic fashion, if I gave you a calendar and I gave you the last 300 dates and a calendar and I gave you the high temperature, right, for the last 300 days, and it was like 68 degrees, 69 degrees, 70 degrees, but it was never higher than 72 degrees, and it was never lower than 68 degrees. And I would say with that sample size or with those observations, right? Those are observations. You've observed 300 of something. Make your prediction of what the temperature will be tomorrow. Now, in your mind, you're already wired to think that. You're like, well, I would look at what the variation, the variability. I mean, if it's between like 68 and 72, it probably won't be higher than 72. It probably won't be lower than 68. It'll probably be in the middle somewhere. And you're right. So basically what I'm saying is your mind's already wired for this. But what we're going to do is I'm going to refine that. And we're going to mathematically put that out. And I'm going to give you algorithms that you can actually prove these things. And then you could make different predictions based on past events. Very important in software. Hey, you might be writing algorithms to determine the probabilities for traffic accidents for insurance companies. You might be writing algorithms for pharmaceutical companies that need to determine the probability of getting a certain condition based on past events. Very, very big field. And we're going to start with it here. Next bullet. I got to speed up here. We're going to do descriptive and predictive mathematical models, which is basically writing predictions on describing all the past events or observations that we had. Now, from there, we're going to change it up a little bit. And after we do some more stuff with theory algorithms, we're going to talk about graph theory, an emerging field in mathematics, very interesting to me, where we're going to talk about nonlinear numbers and like non-Euclidean sort of numbering systems. So this is really interesting because we're going to go into a field, again, that's near and dear to me, for example, imaginary numbers, and we're going to deal with nonlinear quantities, which is really cool. I mean, you want to blow people's mind? That's what you do. Like, we're used to linear quantities, right? Like, if you go to the store and you buy a 6-pack of beer, and then you go to the store tomorrow and you buy a 12-pack of beer, tell me a little bit about that observation. You could say, well, tomorrow I bought 6 more beers than I bought today. Or yesterday or whatever, I bought 6 less beers that I'll buy tomorrow. What you're describing there is a linear relationship, right? Because you could look at one of the numbers and the other number, and you could determine the relationship in a linear fashion. One is bigger than the other. One is smaller than the other, right? That's linear. Now, when we talk about graph theory, we talk about nonlinear numbers. So basically, we talk about numbers going across different dimensions. So you can necessarily have numbers based on 3 dimensions rather than 2. Because if you think of a numbering systems are always in 2 dimensions, at least the numbering systems that you've been used to and you've been taught. When you were a little kid, right, what did you have on your desk? I'm showing my age because maybe you kids, when you were kids, you didn't have desks, but we did. We'd have a numbering line on our desk, right? And it would start with 0. And then when you moved to the left, you had the negative numbers, and you moved to the right, you had the positive numbers. And then your teacher would say, okay, if a monkey gave you 5 oranges and you already had 3, how many oranges would little Bobby have? So you went on your numbering line, and you started with 3, and you added 5 to it, and then you got 8, right? Or you went backwards. That you were learning in 2nd grade, hopefully, Hopefully you weren't doing that in 5th grade, but maybe you were. You were learning linear numbering systems, right? You were learning something in 2 dimensions. And then when you got into high school, or maybe even junior high, you started using graphs. Remember, you had your x-coordinate and your y-coordinate, and then you had your mom had to go to Walmart to get you graph paper, and then you put your x-axis and your y-axis, and then you started writing graphs. Okay, that's still 2-dimensional numbers, you're basically, you have your X and your Y, but you still have linear relationships. We're going to be talking about graph theories in more than 1 dimension. Some pretty cool stuff. From there, we're going to go back in the number theory, and we're going to talk about number theory techniques. Specifically, we're going to talk about non-Euclidean numbering systems, and we're going to be talking about natural quantities versus unnatural quantities, or basically observable numbers versus non-observable numbers. All right, I think half of you are already walking out the door, but let me explain that for a second. If you look around you, you could probably count things. I'm looking around me. I have 1 phone in front of me. I got 3 keys. I have 1 microphone. I have 2 monitors, and I have 3 computers. Actually, I do. I just counted them. So anyway, those are natural numbers because I can look for them, I can observe them. They're natural numbers or observable numbers. I can see them, right? But I'm going to ask you again. I'm going to ask you this. I want you to look around you, and I want you to count how many, and work with me on this, how many, I'm trying to think of something really, really, really strange. How many spaceships do you see around you? Oh, and by the way, a picture of the spaceships don't count. You would say, I see 0. Work with me on this. If you're watching this in space, you might say, I'm in the International Space Station and I see 1. Okay, but work with me on this. I'm looking around me right now. I don't see any spaceships. Okay, look around you, and I want you to count how many airplanes you see from the 1920s. I see none of them. Okay. So you have what are called non-observable numbers. And you also have what are called imaginary numbers. For example, can you look around you right now and see -1 of anything? How many of you can look around you and see -1 monitors? How many of you can look around you and see -1 phones? -2 keys, -3 wallets? You can't. Those are not observable numbers. Okay, so we're going to talk about the different properties of numbers and what makes them special and what makes them unique. Now, a lot of this stuff you probably never thought of before. But hopefully I'm getting your mind going a little bit, because the numbering systems and what we can observe and not observe are going to be fundamentals and paramount to discrete math, especially when we start talking about probability theory and, discrete math for computer science. From there, we're going to go into cryptology. Now, we're not going to jump into it too much, because this is really kind of like another 16-week class. We could just go forever on cryptology, but we're going to at least in the context of what we're doing for mathematical numbering systems and how cryptology works, we'll give you the fundamentals. I'll give you enough that you can get at least a good chunk to put in your pocket that you can take somewhere else, at least take out of your pocket. Then we're going to go to the last bullet here, which I talked about. I'm talking about analyzing and solving common problems. Now, this is kind of a catch-all, and to be honest with you, it's kind of me taking the sucker's way out, because I still don't know what common problems we're going to solve. I'm gonna define this more as we go. So don't panic. It's just, what's the common problem? As we go, I'm gonna define what these are. Bob, don't you know? Well, I do, but there's like dozens of them that come to mind right now. But I'm just gonna kind of pick a few. So I'm just gonna kind of leave that open for what exactly we're gonna be doing. Basically, what I want to do is I don't want to give you really, really super simple algorithms. But I don't want to give you, E equals MC squared either. But I want to get you something in the middle. And I guess why we go through this class, I'll define what that middle is. All right, let's move on. All righty. So let's talk about this class in a little bit more, I don't know, what's the word I'm looking for? Let's talk about this class in a little bit more context. Now, where is our reading? Where is our material coming from? Now, let me give you the short answer. I always make it a long answer. I'll try not to. Reading means reading and viewing now. We use multimedia, or what's called mixed media. The days of going to the bookstore and buying a book are over soon, if they haven't been over for a while, in a lot of courses, and this is one of them. I did give you guys an email last week. I said, don't buy a book. Don't. We don't do that. All of our meetings, all of our, how about this, material, our material, not reading, it's an old word, right? Our material is going to be mixed media online. Where do you find it? You're already raising your hand. Give me a few minutes on that. I'll show you exactly where our material is going to be. All right, hold that thought. All right, now let's talk about our rules for success here. And I kind of put these in here as bullets just for us to kind of have some ground rules on. Now, rules for success: show up virtually. Now, what does that mean? That means be prepared to do your work. Like if you go to work, your boss says, say, hey, man, I need you to show up today. Well, that doesn't mean just be there. That means you got to be there and do something. And I kind of expect you guys to do that too. And I'll do that as well. Sometimes we have days where you don't want to go to class, and quite frankly, I have days where I don't want to talk to anybody. But we got to muddle through those. I'll show up, you show up, and some days they'll be more engaging than others, and my job is to make it as engaging as possible. But please do it, because the more you get into this, the more successful that you'll be. And I said you must choose to attend every scheduled class period. Probably shouldn't tell you this. I don't grade you on your attendance, because you're just like, well, we're taking the class virtually. How do we attend? You still attend. You do. Even before, and I'm not going to say the P word, I promise you, that's the elephant in the room while we're meeting virtually. Not going to mention it. You already get so much of it on the news, so I'm going to try to avoid it. But virtually you attend. You're attending right now. By listening to me, you're attending. So show up, listen to the lectures like you see now. And by the way, this is the last one you're going to get from me when I'm just like showing you all this crap. More or less, the ones you're going to get from me, I'm going to be showing you how to do something. I'll show you how this stuff works, not just explain it to you. Okay, do the work, ask for help if needed. Fine line there. Put some effort in, but have a fine line between I tried and I need help, rather than I'm asking help and not trying. So find that fine line, you'll be fine. Participate. This is going to be difficult because, again, we're meeting virtually. And you know, I don't consider participation everyone being on a Zoom meeting and raising their hand. I don't know. I worked with technology for a living. Sometimes participation, because we all participate differently, right? And I know I'm kind of talking around this, but let me just tell you how I feel about this. A lot of professors say you participate by asking questions. Oh, Bob raises his hand. Bob, do you have a question? Or do you have a comment? Yes, Professor Hendry. This is a very interesting lecture that we have on probability theory. I wonder if you could blah, blah, blah. And, you know, some of it seems to be pretty manufactured. So that's not necessarily participation to me. Some people passively participate. Means that you're quietly taking it all in. You know, you're listening, you're taking it all in, you're getting the gears going, and then after class you send an email or a question and say, hey, Bob, you know, if you have like 5 minutes tomorrow, maybe can we meet on Zoom? Because I got a question for you. That's cool. I mean, that's participation right there. And if you did that, and this, you know, you're all writing it down. And now I'm going to get Zoom requests from all of you, but just listen to the spirit of what I'm saying. Participation doesn't mean you're asking a question because, you know, some professors say, everyone before we leave this class is going to ask one question. I'm like, really? Does that really mean that people are participating? No. But anyway, participate in your own way. Okay? We all learn differently. We all participate differently. If you're quiet, be quiet. You don't have to. Yeah, I want you guys at some level to get out of your comfort zone. But, you know, our comfort zone is where we do most of our work. It just is. You know, so get out of your comfort zone. But if you need to get back in it to get some work done and to get some good questions, you can participate that way. And I'm cool with that, really. I'm not going to call you out and, you know, I might give you some advice, but that's about it. Also, again, be honest. All work should be your own. We're all in the honor system here. So please, 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 you're not going to learn anything by cheating. Trust me. And you want to know what? You'll probably get caught and fail the course. You know, so it's not worth it. I mean, even if you get away with it, and you probably will, to be honest with you, your odds are better than 50-50. I know professors don't tell you that, but if you're smart enough to cheat, you're probably smart enough to get away with it. You're not really doing yourself any favors. So really just don't do it. All right, anyway, I will come to class with a good attitude. Okay? Yeah, usually. Sometimes not so much, but I really enjoy what I'm doing. This isn't like a BS job for me. I mean, I don't do this for beer money or, you know, to pay the IRS or something like this. I mean, I do this because I truly enjoy it. And so that kind of helps me have a good attitude. I'm respectful to your ideas and the value to diversity you bring to the classroom. Okay, this sounds like I pulled this out of a manual that said you got to put this in your syllabus, but I believe this. We all have different backgrounds, right? And all of our backgrounds, you know, we have different experiences and different viewpoints and different ways that we look at it that really contribute to how we look at this in the class. All right, I'm open to dialogue that challenges me. All right, I'm not right about everything, and that's what's cool about the things that we're doing here. Is it's a lot of this stuff is open for discussion or open for interpretation. So if you see those opportunities, take them. Really take them. I mean, this is not, a class or a debate where you win or you lose, and that drives me crazy. Because I always tell people, like even in my personal life, that like for me, it's important to get it right, not to be right. I don't care if I'm right or wrong, and I always say famously, I don't like to be right because being right takes too much time. So I really don't care about that. But I'm open to any of this dialogue. So don't think that you're, as long as you're not trying to be right, you're trying to get it right. I'm completely cool with that. I'll answer any questions you might have. Sometimes I might blow you off if I know it's coming, like in 10 minutes. I'm like, it's kind of wait. I will use different teaching techniques and modalities. I like to use mixed media, meaning I don't give you book assignments. As a matter of fact, there's going to be very little reading at all because I think that there's better ways to learn. And I try to mix it up a little bit rather than giving you traditional, by tomorrow, I want you to read pages 1 through 100,563. I usually don't do that. Well, I don't do that to you. I will give you your assignments back within about a week or so, and I'll give you the best feedback I can. I use a combination of live and remote instruction. You're like, wait a second, we're all remote. Well, yeah, we are, but let me explain this. Live and remote. The material that we're going to be learning is not only going to be me. Okay, like for example, some of the stuff that you're going to be learning aren't going to be me doing a lecture like you're hearing now. Well, now you're seeing me go over the syllabus, but it's going to be me giving you a lesson. But to augment that, there's going to be other things as well. There's going to be like YouTube videos where I've vetted them out, like a really good video on the differences between theorems and proofs and the relationships between them. Some of this boilerplate stuff that is fairly generic, I look at it and with a straight face, I'm like, well, can I add anything more to this than it's already been out there? So what I do is I use some stuff that's already out there. You know, for example, like I would watch, like just recently for one of your readings or one of your viewings, I saw a lecture on, you know, the fundamentals of theorems and putting together good theorems. And I'm like, you know what? I couldn't have said that better myself, really. But this dude said it in 15 minutes and did a really good job of it. So guess what? That's going to be part of your viewing, and I'm just going to focus my efforts on another part. So that way we're doing a combination of different instruction techniques. It's all remote. I know you're looking at that. Well, do we do it live? Well, I probably should change that word. Also, I'm going to help you I'll put the same effort into the course as you do. If you keep trying, I'm trying with you. So keep going. If you need help, ask for it. I'm here to help you. I really am. I know that sounds manufactured, but you know, it's our job to get through this together. It really is. So the sooner we can figure out how that works individually with you, the better off we're going to be, you know, as a class, and you're going to better be as a student. All right, anyway, let's talk about the course schedule here. Now, I'm going to start quickly going through this because I'm really sort of done what I need to do. But here are the weeks. And again, I'm going to spend 2 minutes on this because, you know, we're going to vet this out as we go. But this is where you go if you want to know what we're doing in a specific week. Now, again, this is very simple, but pretty much it's a nice roadmap of what we're going to be doing, what subjects are going to be done, and what assignments are going to be due. Now, this is important, again, to show you about this assignment stuff. And again, I'm going to let you read the topics on your own. I already covered them in the about 20 minutes ago, but this is where they're going to be covered. So that's all I'm going to say about at least the subjects. If you have any questions, ask me. But let's take a look at these assignments and the grading here. Now I got everyone's attention, right? The midterm and the final, I really de-emphasize. And again, this has to do with, you know, the professor and me that didn't like going to college because I didn't like it. Well, I did, but I didn't like tests because they freaked me out. You know, I had professors that would give me, you know, 50% of my midterm and 50% of my final. And, you know, I'm just like, you could go all the way to week 15 and knowing that 50% of your grade still is not determined yet. I mean, that kept me up at night, especially, you know, if you're a smart guy like me, but you weren't exactly a genius. You know, I mean, I could F this up. And I'm like, oh, no, I don't want to do this at all. So I kind of take that into me being a teacher where I'm like, you know what, I don't think we really need to do that much for the midterm and the final. So let's take those points and put them in the weekly assignments. That's where they should be, because now what I'm doing as your prof is I'm taking 80% of your grade and I'm putting them, I am handing it to you right now. Put those in your pocket. You have Right now, you have control over 80% of what you do between now and December 17th. Okay, that's a lot of power. Okay, so you do well in these assignments. It kind of doesn't matter if you need the ace of the midterm and the final. I mean, you have to do well if you're looking for your A or your B, but you don't necessarily have to. It's not, you need to do good on these, otherwise you're kind of screwed. I mean, your weekly assignments kind of do it for you. And let me show you these assignments. And again, these are approximately when they're due, which week they're doing. Now, here's the thing. Now, don't say this too loud. This is just between us, okay? All right? Is everyone left the room? All right. For those of you that are not in our math class, leave the room. Okay. All right. They're all gone. It's only you and I here now. All right. Now, I don't count these late if they need to be late. So when these things are due, and you'll see an assignment in a second, if you can't get them done on the due date, don't sweat it, okay? Now, be careful. Now, keep listening, okay? Some of you tuned out. That doesn't mean you don't have to do your assignment. It just means that you have extra time for it, okay? So if you're late in assignment 1, 2, 3, and 4, and you start, stacking them up, you're going to run into problems. Yar. Some of you are looking at this like, oh, you know what? I'll just start working. No. If you wait and start doing this stuff, you may be successful. I'm not going to lie to you. Some students have been, but most have not. Most run out of time. They're like, holy shit, how in the world am I going to get all these done? This is a lot more difficult than I thought it was, and you run out of time. So the due dates on the assignments that I'm giving you are suggestions. This is where I think you need to be to get this stuff in. And I'm realistic. Okay, I'm serious. I don't look at it and say, well, let's just shoot for getting it done next week rather than 3 weeks. I'm realistic. I'm like, you know what? You don't really need to get it done next week, but you certainly need it done the week after. So trust me on the dates that I give you with this. I'm not accelerating it for no reason, because that drives me crazy. When people say, well, can you have it done for me next week? And I'm like, all right, when do you really need it done by? Well, next week would be great. And I'm like, no, you don't need it next week. I know for a fact that this stuff isn't due to the end of the month. So how about in 2 weeks? Well, 2 weeks, I'm like, no, 3 weeks is cutting it. 2 weeks is reasonable. 1 week is just a wish. You want it done in 1 week. I don't do that to you. I try to be realistic where you should be in the course. So trust me when I give you these dates. This is where you should be. But if you can't make them, don't worry about it. Take that back. Don't worry too much about it immediately. Take an extra couple days, maybe a week, and get it done. Remember my saying, it's important to get it right. If it takes you a little bit longer to get it right, take a little longer to get it right. This is why we're in school. We're learning this stuff, okay? That's why it's okay. I mean, if you need to take some extra time, you can do it. But anyway, here are the assignments and when they're due. Now, we also have the grading. Not surprising. This is just the standard college grading system. Got to put it down in here. All right. Couple more things and I'll be done. Promise. And then we'll be done the next class. Now, here is how you sign in for attendance. Every day when you're in class, sign the attendance sheet. Now, where is it? Go to the syllabus. Okay, and I'm going to say this again. The syllabus is the center of everything. It has our assignments on it. It's got our attendance sheet on it. It's got everything. So that link I gave you for the syllabus, bookmark it. Seriously. You're going to go there a lot. Will the syllabus change? Well, no, but that's where your links are going to be. That's where your links for your attendance are. So you're like, Bob, I forgot where the attendance link is. Go to the syllabus. That's where it is. So just to show you once, you click on our attendance, and you will navigate to our attendance sheet. Now, here we are, CIS125. That is you. All you need to do is just look at the date and put a little X there. That means you were here. Do you remember in the old days we used to pass around that sign-up sheet? This is the same thing, except we don't pass it around anymore. You go there and you check it off, right? Now, the question of the day. Got an email from a student saying, okay, Bob, I found the attendance sheet. Now, how do I fill it out? Okay, this is what you do. I'm being sarcastic. Find a name that resembles you here on the left. Once you find it, find the day that it is, like today is the 25th, and put a little X there. And that's it. You're done. That's how you attend class. So that way I know that you're here if you're not here. Do I check this all the time? Not really. But be honest about it so I could at least see which ones you've missed. Like I said, there's not really an attendance grade, so there's no incentive to lie about this. That's why I don't give an attendance grade, because I don't want to give you a reason to lie about if you're here or not, right? If there's no attendance grade, we could be honest with each other, right? So if you're not here, just don't click it, and then that way, at least, pardon me, if you're having a challenge grasping a topic, I'll know why. I'm like, oh, okay, Bob wasn't here the 27th, the 1st, and the 3rd. You're not in trouble. That's fine. I just know that I covered it and maybe you just didn't get it. So it makes sense. So anyway, that's your attendance sheet. So I'm going to close this. So now you know where your attendance sheet is. Now, one last thing and we'll be done. Also, on our syllabus, you're going to hear this a lot, on our syllabus, you're going to see our assignments. Now, we're going to have 10 of them, right? How many assignments do we have, Bob? Well, look at the syllabus, and we have 10 assignments. Now, not all of them are assigned to you yet because we haven't got to them. But as we go through the semester, I'll start probably pre-posting them. You know, maybe a couple of you can get ahead if you want. But I generally try not to do that. But anyway, here's where you're going to see these. Now, I'm going to pause here for a second. So I want you to do. This is what I want you guys to do. Now, here is how the assignments work. Every week, approximately, I'm going to post an assignment on here. CIS125, assignment 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and whatever. Now, here's the thing. I want you guys to be responsible for checking the syllabus a couple times a week. Doesn't have to be more than that. As a matter of fact, Tuesdays are a good day to check this. Thursdays are a good day to check this because that's technically when we have our classes, right? Tuesdays and Thursdays. And take a look at the assignments and see when they're actually added. Now, why would you want to do that? Let me tell you a little bit about my style, okay? You're almost never going to get spam emails from me other than like maybe the first week. I mean, because I sent you one today, right? So, but other than that, I'm not going to give you reminders. I'm not going to say, hi everyone, now this is, remember, a friendly reminder, this is the second week of class, the week of September 1st. Please remember to blah, blah. No, I don't do that. Okay, because you know why? Because you know where to go. You don't need a reminder to check the syllabus a couple times a week for the new assignments that are posted. There's other reasons I do that. And one is courtesy. It's less crap for you guys to open. Does that mean I won't email the class from time to time? Well, of course I will. Sometimes there's something I got to get across to you immediately. I'm like, you know what, guys? I usually don't do this, but here. Usually, like I said, I don't do that. I think emails run its course. People start to ignore it. You know, so, and plus if I send you reminders to things, if I forget to send you a reminder, you're like, Bob, you didn't send the reminder out. With that, pretty soon then we're sending reminders for reminders. So I don't send emails. And you're just like, wow, that's really strange. But believe me, you'll find this refreshing. You really will. Because you know what? You're all grown. You're all grown adults. You don't need reminders. You know you've signed up for the class. Go to the syllabus a couple times a week. Look for if any assignments are added. If you have questions, you could email me. I didn't say I'm not going to respond to your email. I just said I'm not going to spam you. So, I mean, you can email me and say, hey, Bob, this is Don from your 125 class. When are you going to post assignment 3? I mean, I'll respond immediately. I'm like, oh, yeah, I'll post it at the end of the week. So when I'm saying I don't send emails, I'm saying I don't spam everybody. But I certainly answer them. But anyway, so that's what I want you to do is go to these couple times a week, find these assignments. And I know what you're thinking. You're like, Bob, what if I miss something? What if you posted a link on Thursday and I don't see it and you send me Okay, no, let me explain how this works. Like, for example, I'm going to go on assignment 1. I'm going to click on it. Now watch what's going to happen. This is the assignment 1 for CIS125. Notice how paperless we are, by the way. Love it. No, we are like paperless. Let me just open up our assignment, right? Here it is. This is assignment 1. Opens up in our browser. And 2, there's going to be a couple things I want to mention. First of all, number 1, you're going to get the assignment number, right? You know this, right? It's assignment number 1. Okay, there you go. I know you guys were smart. Look at the due date, September 7th. Anytime I post an assignment, I will give you at least, okay, say this again slowly, I will give you at least 1 week to do it. Usually 2 weeks to do it. So that should answer your question about what if you post an assignment and I don't see it immediately? That's okay. Just check the next day. It's okay. It's not, you're not going to miss something. I'm not going to post something and say, this has to be done by tomorrow. No. I don't do that. That's not fair. When I post an assignment, I'll give you at least 1 week, most likely 2 weeks to do it. So that way, if you don't check the syllabus for new assignments on Wednesday, and you can't check it on Thursday, but you check it on Friday, you're like, oh yeah, there was an assignment that was posted. You're okay. Now, if you check the syllabus once a week or once every 2 weeks, you're probably in trouble. But don't do that. I mean, just check it. You know, if you want to check it every day, fine. I'm not going to post something every day, but if you want to check it a couple times a week to see what was posted, do it. I'm not going to surprise you with something, okay? You're not missing anything, again, unless you check it once a week or 2 weeks. Don't do that. All right, anyway, so this is a simple one. And I usually have the assignment, and this is what I kind of say. You know, this is actually kind of a test one, to be honest with you, just to get you in the swing of things. And I say that there. Just want to get you in the swing of things. And then in the assignment, I have the do. This is what I want you to do, right? Very easy, do. I usually have like a do 1 or a do 2. If I want you to do 2 things, I say this, do 1, do 2. Sometimes there's a third, do 3. Here we just have 1, do 1. So this is your assignment, all right? You know, in 100 words or less, what's the relationship between a theorem and a proof? Submit your short answer to me via email for grading. Usually that's the format of the do, what I want you to do. Now, to answer your question, where is your material, your reading and your viewing? Let me say this slow. You will always find them here. Go to your assignment 1, assignment 2. In the viewing section is going to be your material for that week. Usually they're going to be videos, like me doing a video. You're going to see that a lot. You know, I'll say, hi everybody, this is Bob, and we're going to do this in CIS125. And there's going to be other ones. There's going to be links to YouTube instructional videos. There might be a link to a PDF file. A variety of different things, right? You guys aren't new. You've been to school before, right? You know how, your assigned stuff goes. This is where you're going to find it. Bob, I can't find the links for the viewing. Okay, go to the syllabus, find the assignment 1, assignment 2, click on it, go to the viewing section. That is the material that you need to do for that week or for that assignment. You don't got to look anywhere else. There's no email. Don't you love this? There's no emails to dig through. There's no Bob saying, if you remember on the 25th, I sent an email, blah, blah. No. There's no emails to dig through. And that's another reason why I try to email you guys, at least, as a class, as little as possible. Okay? Because who likes digging through email? Nobody. So I don't do that. I don't let you guys do that. I try to keep this recipe simple. This is what you do. Again, a couple times a week, go to the syllabus. Okay, and the syllabus probably isn't going to change, but the assignments will. Go all the way down, and while you're going all the way down, you see the sign-up sheet. You can click on it and sign in. I was here today, Bob. Good. Okay, click on the assignment, or see if there was an assignment. Like I said, there's only going to be, an assignment every couple weeks or so, or, maybe one a week. Go to the assignment. When you click on the assignment, It's going to have what your assignment is. It's going to say when it is due. It's going to say what you need to do, and it's going to have your viewing. Now here, your viewing is only, it's only 2 links. It's going to be more than this. I mean, pretty soon you're going to get, more than a couple days worth of stuff to do. But we're just getting our feet wet here. So this is how it works. Anyway, I'm wrapping it up here. This is hopefully the most boring class you're going to have for me, just going over all of our stuff. And that's what we did here. My goal for you guys was to kind of tell you what this class was about and the formula for how to handle it. What do I do? Okay, well, what you do is you go to the syllabus, you have the link, go to the bottom, look for the assignments, and then go to viewing. And then you're going to have me there as part of your links. Hi, everyone. This is assignment 1. This is what we're going to do. This is kind of an exception because you're kind of watching it now. And then you're going to have the rest of your viewing, and that is how you approach this course. That's what you do. Also, as I kind of point out to you guys, I am very reachable, and I'm text friendly, Zoom friendly, Skype friendly. I mean, if you Zoom me like now or Skype me, I probably won't be able to get to you, but I can make an appointment. I mean, usually within the day, maybe within the next hour or so. So I am reachable. So I don't want you to think that even though most of you will be watching me on some sort of like tape, like that's not tape, or like a video like now, not in real time, that doesn't mean that we won't do a real time. All of us will do a lot of real time. As a matter of fact, I use videos like this to save us time, because if I do these videos and I don't use our wink wink class time to do that, I can spend that time on individual instruction with you guys, right? So that way, you're not sitting there all listening to me do the same thing when you could just frankly listen to me do this anytime, and then we could spend more quality one-on-one time doing Zoom and Skype, blah 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 blah. Little on that later. After week 2 or 3, if I don't hear from you guys, I'll start encouraging you to participate via asynchronously during the week. Like I might do that like in week 2 or 3 if I don't hear from you. Say, hey, Cadence, I haven't heard from you. Can we meet for 5 minutes or 10 minutes later this week and just chat? I'm not gonna come in peace. I'm not gonna knock on your door and ask if you've done your work. I'll ask ask a little bit about you, introduce myself, and kind of get a dialogue going. Because I don't want you guys to feel that you're out there just clicking buttons and taking class that way. I want you to feel that this is meaningful and there still is a human element, because there certainly is. All right, folks, that's all I had for you today. Sorry about the long-winded class about nothing, but I wanted to get you all set up for success and get you all ready to go into this course. You're going to have fun, and you're going to learn a lot, and we'll all get through this together. All right, folks, thank you for your time. Thank you for making it this far, and I bid you all a very well, healthy, and safe rest of the day. Thank you. Bye-bye.